Welcome back. In this video we're going to look at how to detect the collisions of the tetraminos. So presently we've got the tetraminos falling and hitting the bottom, which is great. But the issue we've got is that when we bring in the next tetramino, which we'd like to layer, well, I'm gonna do it wrong here. I'm gonna put it on top. It actually falls right through. And so what we're going to have to do is a little bit of programming to get it to detect the collisions. Now, unfortunately, we can't just use sort of physics and just have it, bounce off of each other or whatever. We're going to have to program this in. So back to the game manager, and I've actually already put in a little piece of code here. Just let me make this a bit bigger so it's easier to see. And there we go. All right. So a little piece of code I put in is just sort of to start this off here. What we're going to do is create an array. And so an array is just a series of data points, basically, that we're going to use to record where where the tetraminos are. All right. And so we've got at the moment a grid width of 10 and a height of 20. And so really, if you think about that, that would leave us with 200 potential locations, okay? So if you imagine, 10 across, 20 the area, each of those squares, and that a tetramino can be existing, is going to, we need to keep track of where it is, and if it's got a tetramino, or if it doesn't. And so that's what's going to happen here. This is the piece of code I've put in so far, okay? So it's a transform we've seen before, but it's got this square bracket around it indicating that it is a array, okay? And there's two pieces of information going to go in there for each array component. And you can see here, it's going to be the grid width, so a value for the X and a value for the Y. Now every time that a piece lands, we're going to need to update this array so we can keep track of where the pieces are, and then when the next piece falls, we can sort of check for a collision. All right, so now that we've got that in, we've actually got to do a bit of programming here, and I've actually put it in already. It's this section here, so you might want to just pause the video and copy this code in, then I'm going to explain it here. All right. So the big idea is that every time a piece lands, we need to call a method, okay, and this is going to be the upgrade grid method here, okay, with this function. We're going to call it from the tetramino class. So it's going to check, because remember the tetramino classes, or the tetramino controller is what's allowing it to move and sort of get its position there. So we're going to call this method from multiple areas on that tetramino controller. We'll do that in a few minutes here. And basically what we need to do is not constantly, but every time we sort of have this piece coming in, update the grid array so we know where our tetraminos are. Right? The computer can't just see them visually. So what I've got here is a public, okay, because we're going to have to access this from the tetramino controller. Update grid, we've called it, which makes sense. And again, we're going to pass in from the tetramino controller the tetraminos, okay, because we need to know where those are. Now there's two for loops here, and basically what these two for loops are going to do is iterate through the grid. Like I was saying, there's 200 locations, and so Y represents basically the height, right, and X is the width, so they're going around horizontally. And so what happens is that it needs to go through all those 200 positions, and it's going to go kind of row by row and sort of work its way, well, I guess up or down. I can't remember which one Y is 0, and sort of, I guess, work its way down. And so if this is the first one, it's going to be at basically row 0, okay, so we're on the height, and then it's going to go across at each one. So you'd have 0, 0, 0, 1, 0, 2, 0, 3, and so on to 0, 10, because we've got 10 in a row, and then it would move up, and it's going to do 1 for y, and then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, until 1, 10, then it skips up to y2, and then does the same process over and over again. So in that way, you'll have 200 sort of checks that it's done. Now, of course, there's the limit based on the height that we've defined up top, 20 and 10. This here, we've often seen y++ or I++ or whatever the iterator is. Don't worry too much about the difference there. So ++y or y++, they might work the same in this situation. We could experiment a little bit later and see. They're both incrementing the variable. There's a little bit of a difference. Some of the explanations I've read are a bit wrong in terms of saying that this will increment first and then check. It has a little bit to do with how the value is stored temporarily, but for our purposes, I don't think we should worry too much about it. So the next part of the code gets a little bit confusing here. We've got two if statements, okay? And basically we're checking to see how they change over time. So it's got here, if the grid xy, so this coordinate position that it's checking, is not null. So if there is something there, okay, so at the start, they would all be null, but if there is something present, and if this, basically this position, don't worry too much about the parent there, but if this position is the same as the Tetris09 transform, then because it's constantly changing here, it's going to move down, we're going to set that position to null. So because it's moving each time, and we'll see that a little bit more with the Tetris09, where we call this update grid, it's going to be called when we move something, then it will be set to null. Okay. Now, the other little bit down here, so we close all this up. Okay, so make sure you got all the right number of brackets there. We close it up except for the update grid. Okay, that function is still going here. Then we do for each. So it's going to run through, sort of iterate through each Mino, okay, in the Tetris09 transform. So it's going to run through each Mino is made, or Tetris09 is made up of the 4 Minos. Okay, so it's going to run through each of those in the Tetris09.transform. So it's going to find the position for each of them. Okay, this round here, it's going to round it to an integer. So it's going to take that Mino's position. Okay, and if the position is less than the grid height, so we just want to make sure that we're keeping it within the grid, what we're going to do is set the grid, so this value, as our x and y in our array here is basically the position of the x and position of the y. This is casting or changing them into integers. They are coming across as floats, okay? And so that value goes in as for the Mino's position. Okay, so we'll have a value for x and y in the array, whatever the Mino is. So the complication is that you have a Tetris09, but the Tetris09 itself, although it has a center, it has 4 other Minos attached to it. And so each Mino will take up 4 positions. And that's what this is doing here. It's going through each Mino, okay, to assign sort of the position there. Now what we need to do is go to the Tetris09 controller and basically call this function here. So in the Tetris09 controller, we left a variety of things here. So for example, at the very top here, we've got check is valid position because we hadn't done that before. And so what we're going to do is a little bit of code here. Find object. Keyboard's going here. Okay, okay, caps lock. Object of type. And we're going to look for that game controller. Oh, sorry, yeah, game manager, I've called it. integer, if I can spell. Okay, and we're going to find the update, what did we call it before? Update grid. And we're going to pass the value. It's going to be this tetrameter controller. So instead of putting tetrameter controller, you can just call that this. And find object of type. Of course, needs another capital here to make everything happy. There we go. And update grid. It's not liking that. I wonder if it's just not finding it. Let's just go double check. Update grid. Should be okay. I think it's just not being happy. Just making sure it's spelling that right. Okay, it could be just because I haven't saved too. So let me just make sure. Oh, no, I did save that one. Okay. We'll see what happens here. All right. I'm just going to go to Unity and make sure. No. 30. Tetrameter controller. So it's not happy with this. Just let me see what's wrong here. Of course, when I pause it, it's easy to see. I forgot to close that angle bracket there. Good. There we go. So like I said, this is going to run, okay, when you press the key, okay, to get it to go down. We have to make sure that that's the valid position. Now we're going to copy this and we're going to put it in a variety of spots. Okay, so make sure you've got that copied. And as we run down here, there's a few spots. So check valid position. So again, I'm going to plop that in there. And as we go down further, we have to go down to the rotate as well. So let's just see, check is valid position. There it is. So basically you're just filling in these check is valid positions. Okay, and it should just paste in there. And the other one for our down and fall. So there it is there. Okay, so where we had left the code sort of empty before, now we can fill that in. Oops, let's put that back with this check here. So we're almost done here. We'll end this video and just come back to finish it up. And when we've got that done, we should be able to play the game so that the tetrameters fall and they can, collide with each other so they can sit on top of each other. And that should be a pretty short video there. Okay, see you then.